All right, guys, so we have already defined phasors, and we already took a look at a resistor and what Ohm's law looks like in the frequency domain. We just took a look at the inductor, and we saw what the IV characteristics look like in the frequency domain. We have one last passive element, ideal basic circuit element, that we really want to concentrate on, and that's namely the capacitor. So here, this is part 3. This is the capacitor C. So suppose that we happen to have a capacitor characterized by capacitance C. We place a voltage across this capacitor. We know that the current is going to flow through the capacitor from high voltage down to low voltage. And the IV characteristics for the capacitor, the relationship between the voltage and current, are given in the following way. So the IV characteristic looks like this. The current in the capacitor is equal to the capacitance times the time rate of change of the voltage, right? Keep in mind that this can also be rewritten in integral form. The voltage is equal to 1 over the capacitance, the time integral from initial time t0 to t. The current integrated with respect to time, plus whatever voltage existed in the capacitor at time t0 like this. Keep in mind that both of these contain the same exact amount of information, right? Now, one thing that we've talked about for both the resistor and the capacitor is that inductor is that this is in full generality, right? But we want to take a specific look at the sinusoidal response. So here we're actually going to assume that for simplicity, and this is for simplicity, that the voltage across the capacitor is sinusoidal. It has some magnitude times the cosine of omega t times the phase constant for that capacitor, by following essentially the same identical arguments that we followed for both the resistor and the inductor. And I'm going to leave this as an exercise to you guys. One of the things that we're going to be able to show, given this assumption, is it can be shown that in the frequency domain, that the IV characteristics for the capacitor become the following. The phasor voltage for the capacitor is equal to 1 over j omega c, where c is the capacitance, times the phasor current. And this is the result that we actually wanted to get to.